No, you want pure magnesium. Because any magnesium that's contaminated is not going to last. Very important that it's pure. Well, yeah, but it's got other things mixed with it. Any more questions? How does the oxide form? Well, it's actually on the outside too, but I just didn't take the black off. I didn't scrub it off. I actually stuck my finger in there and rubbed off the outside on the inside. So if you look at this one, you can see the black on this one right here. See the black on the outside? Yeah, it's real delicate. Right. No, if you scrub it, you're going to scrub that semiconductor layer right off the copper bowl. Then it's not going to be the one-way gate. And you can test this yourself by taking a piece of copper and heating it on your stove, and you get that reddish-looking copper on the top. And if you take an ohms meter and you scrape the copper on the bottom so you can make connection, it'll only go one way with the meter. It'll work just like a diode. There's no problem doing that. In fact, you could make some high voltage rectifiers that way for that machine. The cheap man's diode, but it's far better when they work than the diodes we're buying. There's obviously a reason they took them off the market. It's discussed on the internet. In fact, I think they used to make, I think they replaced that rectifier with a rectifier called selenium, which was very poisonous because they can take the high voltage. So this works pretty well. Nothing goes back.
What kind of amp current can you get out?
That depends on your surface area. Like I said, I do this as big as possible. So this is probably producing, if I was to do it all over again, recook it again, get the best semiconductive material I could on there, start over, use the same chunk of magnesium, I could probably get 1/2 ampere at 1.1 volts. So it's not that it doesn't have enough current, it does, because it wouldn't run the oscillator circuit if it didn't have the current. But it's like, the cell is like, no, I have to hook this up. The cell is probably 0 like this when it's dry, as far as the curve goes. And then you add the moisture to the crystal, and it's going to pop up like this, and then it's going to stay like this until it dries out, which is going to fall back down. So it stays with this eye continuous. It's staying right there. Now, if I add a little bit of moisture to it, then it's going to come up a little bit more. This line will move up here. So when we look at the crystal batteries, I'll raise it, and then if somebody needs it, I'll put it back up. The idea is, you're making the crystal battery, right? And you're doing it with rocks. Then you're just crushing up a bunch of rocks, and you're making little pieces like this. And they're all different shapes, right? And whatever you're cooking this mix with, which is usually barium titanate, and a few others, strontium and things like that. Okay, I don't want to work with those chemicals. I don't want you working with them. They're chemicals you don't want to work with. You don't want to be cooking this on a stove and breathing that. So, when they say, well, we built a crystal battery, right? They say, okay, look, this one's alive, it lights the LED. It's doing the same thing as that, and it's just running along like that. And it's changing with the gravitational wave. It's known from all the reports that crystals, if you can detect it, will change with the gravitational waves. So the point here is, yeah, I can keep this for 2 years or 3 years or 5 years, but I have no output. I have maybe 0.15. Well, what can I do with that? I can't do anything with it. Yeah, I made a crystal battery and I lit the LED, you know, because I had a string of them. But I can't do anything with that. I need something that I can do. I need to be able to generate something that I can tap. You have to have something practical. If you have no power, and if you have no power at all, and you can have light, and you can recharge an iCAD battery, that's practical. You know, I've never been able to get anything more than 0.15 to 0.25 out of grinding up rocks. And that means going out in the front yard and picking up all the white and gray rocks and crushing them all up and buying these iridium electrodes and everything else that just does better. It lights the first time. I don't have to work. I can do this easy in my backyard. I can light my whole backyard up for a couple of drops of water. So it's pretty practical. And if you needed an emergency light or an emergency beacon or an emergency transmitter, that's the way you would do it. You would look at it practical. You wouldn't look at it, I developed this and blah, 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 and tapping the ether and all this. I wouldn't do it. I gotta see it in front of me. And you gotta see it in front of you. So you know the way this works. It's burning the water. We can get little drops of water off leaves in the morning. Doesn't make any difference. But this, when I really need some power, where am I going to get these chemicals where they're shipping you, you know, maybe a little bottle of chemicals like this, and it's costing me $200. Why am I going to do that? This is expensive enough. The copper bowl is about, I think about $7 each, this size, and then $3 each, and then some other one that's $10. Now, there was one copper bowl that I did order, it didn't arrive. I kind of wanted it to arrive before this, because I actually did want to make it. And the copper bowl was this